Hello, how to determine the acidity and the basicity of salt solutions. So today's presentation explain how we can identify the pH value of the given salt. So when acid react with a base, a salt and water are the products. So salts can be acidic, they can be basic or the neutral. So you know acidic, basic and the neutral, the pH values. pH scale is driven from 1 to 14. The midpoint pH is equal 7, we called neutral pH. And pH is less than 7, we called acidic pH. And pH is above 7 is basic pH. Now the salt general formula is M plus A minus. So the cation part always coming from a base, and the A minus is the anion part coming from the acid. That's how the salt is formed. So let's say example. Sulfuric acid, H2SO4 combined with the weak base magnesium hydroxide. So acid plus base form a salt magnesium sulfate. So here magnesium is a metal. Metals normally losing electron to form cations. So Mg is our cation, sulfate is our anion. It's a polyatomic anion. So cation coming from a base, anion coming from the acid. So take another example. HCl is a strong acid, KOH is strong base. So here KCl is our salt, potassium is a metal, the metal part or the cation coming from always base, and the anion portion coming from the acid. Now salt derived from a strong acid and a strong base that form a neutral salt solution. So if we dissolve this type of salt, the pH is equal 7. It's not going down or pH is increasing above 7. pH is in the neutral level. Let's take example. Potassium chloride, KCl. So how KCl is formed? By mixing potassium hydroxide strong base and HCl strong acid. So strong base plus strong acid, if both are strong, then the pH of the salt is neutral. pH is equal 7. Next, a salt derived from strong acid and the weak base. Then the salt solution should be acidic in nature. That means it's more to the stronger side. pH is less than 7. For example, ammonium chloride salt. Ammonium chloride salt is formed by joining ammonia weak base when react with HCl strong acid. So here weak base with strong acid, then the pH of the salt go to stronger side, that is pH is less than 7, acidic pH. The third situation is when salt derived from weak acid and the strong base. So if the weak acid plus strong base, the pH of the salt is go to the stronger side, that is basic, pH is above 7, greater than 7. For example, sodium acetate. Sodium acetate salt is formed by when mixing sodium hydroxide strong base with acetic acid weak acid. So strong base with weak acid, pH should be the basic side, it is greater than 7. So that's how in these three situations how we can determine the pH of a given salt. First thing, you need to identify the origin of the acid and the base, and then depending on the acid base strength, then you can identify the given salt pH. Now what are the strong acids and the strong bases? There are 7 strong acids and 8 strong bases. You can see strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acids. And in addition to these hydrohalic acids, nitric acid, sulfuric acid, chloric and perchloric acid. These are the 7 strong acids. In addition to these 7, all the other non-acids should be weak acids. Now in the right hand side, strong bases. What are the strong bases? You can easy to remember if you go and refer the periodic table. The periodic table, group 1 cations, group 1 elements lithium, sodium, potassium, rubidium, cesium, and group 2 beryllium, magnesium, calcium, strontium, barium. So let's go to first group, group 1A, that is alkali metal groups. Alkali metal hydroxides are strong bases. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide and cesium hydroxide. So if you can easily pick 5 bases from group 1 and 3 more bases from group 2, alkaline earth element. So group 2 first elements, beryllium and magnesium hydroxides, they are weak. But starting calcium, they are strong bases. Calcium hydroxide, strontium hydroxide and barium hydroxide are the other 3 strong bases coming to this strong bases list. So that's how 8 bases are formed, 8 strong bases. All the other bases are weak. For example, ammonia and pyridine, there are 2 weak bases. And for the weak acids, HF, hydrofluoric acid, and acetic acid, CH3COOH, they all are weak acids. Now, we have some examples to practice. There are some salts given here. You need to determine the following salt solutions are acidic, basic or the neutral based on the concepts we learned in the previous slide. Let's take one by one. Ammonium bromide. So what is the origin of ammonium bromide salt? What is the acid and the base we mix? Ammonium bromide, ammonia weak base plus HBr strong acid. So weak base strong acid means pH go to the stronger side, pH less than 7, acidic. Next, sodium phosphate made by sodium hydroxide strong base plus phosphoric acid. Phosphoric acid is weak acid. So pH is stronger side, that is greater than 7, basic. Next one, lithium nitrate. Lithium nitrate salt formed by lithium hydroxide strong base and HNO3 strong acid. If both are strong, the salt pH should be neutral, equal 7. And the next one is same, rubidium iodide, rubidium hydroxide strong base joined with strong acid Hi, hydroiodic acid. Then the pH again neutral is equal 7. Potassium sulfite salt is formed by potassium hydroxide strong base react with sulfurous acid. This is not sulfuric acid. Sulfuric is the strong version. This is sulfurous, OUSND. So the pH is stronger side, that is basic, greater than 7. Next one is sodium acetate. Sodium acetate, like we discussed earlier, sodium hydroxide strong base will react with acetic acid. Acetic acid here, weak acid. So the pH is above 7, basic. The last one is ammonium sulfate. Ammonium sulfate salt formed by when ammonia weak base react with sulfuric strong acid. So the pH is less than 7, acidic pH. I hope now you all have a clear idea about how we can determine the pH of any given salt. Thank you for watching. If this is helpful, and please subscribe the channel and comment any specific area if you need to discuss, and please share with your friends.